Hello there. I want to give you a quick overview of a program that I wrote to solve a problem I have. It's called Experience Tables, and it just solves a problem that every tabletop role player has if they've been playing for any length of time. At the end of a session, and when you've been playing for a long time, you just want to know how many points is my character supposed to have. And there's lots of ways that we've done this over the years, but usually involves scratch paper. So what I came up with here is we have a nice simple text file. It looks like this block right here. And I just write down as the game goes on, this is the character, this is how many points they got, this is why they got it. Then at the end of my session, I run my program, give that file as an argument, and it totals up all the points they have. And maybe more importantly, I can give it a directory of all of these experience files. And it'll tell me how many points the characters have total. And that answers a big question that we always often have in play. So take a quick tour of this code. So the basis of everything is this experience event, those YAML entries that you saw there. Experience events are simple. It's a structure. It doesn't even have methods. It's just a character, the number of points, the reason they got the points. A couple of operators here for sorting and for comparison. Some of these are necessary for the library. Some of them are just nice convenience functions for me. The core of this is the core of the file reading is the YAML CPP library. YAML CPP provides a really simple interface for serializing and deserializing data objects. So to serialize an object, I just say this YAML node has a property called character and points and reason, and I assign the values to them. When I want to decode it, it's the same thing but in reverse. Say, hey, there's something called character. Give me that value as a string. I'm going to make that the value of character on my data object. Now, you'll notice that this also allows validation. If I return true out of this decode function, it means I successfully decoded it. If I return false, it means something's wrong. This isn't really the data type that I expected, or it's malformed. And my validation here is really simple. I'm just seeing, do you have three members? If they do, great. We're considering it valid. But you could add a lot more complexity there if you wanted. Because we're manually grabbing nodes and assigning them to members, we could also add a lot of logic in here to look for errors related to consistency, or we could maybe make YAML a little more forgiving. We could have multiple valid names for nodes, or we could allow capitalization. Lots of options for us, and I absolutely love that. So we talked about the experience events. Experience events, I'm sorry, they don't get added up into a game summary. When they get put into a file, that file becomes a game day. And the core of a game day is just a vector of experience events. It also has a file name. That's a feature that's not used right now. I'm hoping to add it later. This really actually violated some of my principles about don't do work you don't need yet. This may come out if I never implement that feature. A game day, just like an experience event, has a YAML converter. And in this case, we're using it to read the stream of nodes, quickly convert those nodes from YAML to experience events, and push them into our collection of experience events. Now we take game days, that collection of events, and we pass these to a day summary. And this is the core of the program here. This class is immutable, and so if you don't pass something into the constructor, you can't change it. And that simplifies a lot of logic elsewhere. But we've got two constructors that are worth noting. We have one constructor that takes a single game day, which corresponds to a single game day file. And we have a constructor that takes a vector of game days. This would correspond to a directory full of game day files. And so we also have our indexing operator just like you'd use on a map type object. It takes a string and goes and finds, does that string, which corresponds to a character name, exist in our map of totals here. If it doesn't find it, rather than crashing, what it does is to return a sensible default, which is 0. Hey, I haven't seen anything for that character yet. Maybe they didn't play this game, so I just want to return 0, but I don't want to crash. We also have a couple of iterators. And again, because this is a immutable object, I can just use const iterators. And these are just a pass through to the beginning and end of this internal map. One of the reasons it was important to me to encapsulate that was right now I'm implementing this as a map. There may come a time when that's not the best way to do that. I really wanted to hide that implementation detail from any consumer of day summary. And the value out of this, putting these iterators here, is that I can use this in a for loop. Those lovely C++ 11 for loops that give us free iteration over any kind of container. Absolutely love those. So day summaries, let's go look. The internals of this are worth looking at. So if we just get one game day, all we do is we call this add summary function with the game day. If we get a vector of game days, we iterate over that vector using, again, those C++ 11 for loops that I'm so fond of. And for each game day, we add it to the summary. And there's no magic down here. I'm just iterating over every event in a game day. G is our game day, events are the events in it. I'm iterating over every one, looking up, do I have the totals for this event yet or not? For this character. As you can see, we're finding based on character. If I don't have it, add a total for it here. Add their points to the total. If I do have it, add the points for this event to their existing total. Nice and simple, no surprises. The main function is here. And this is a little crude and it wants refactoring, but it's pretty basic. The really big thing that I like out of this is in C++ 17 we now have access to the file system library. This simplifies cross-platform development. So I can use this on a Mac, I can use this on Windows, I can use this on my Linux machine where I actually run my games, and the code doesn't change. So we require as an argument at least one file name. It needs to be a YAML file, or it needs to be a directory. We're using the file system library again for a quick existence check. This saves me a few lines of code, saves me managing some variables. If the file doesn't exist, we return, say, hey, this isn't right. Again, I'm using that library here to see, is it a directory? Well, it's a directory, I have different behavior. If you give me a directory, it means we've pointed me to a campaign, which is a vector of game days. And of course, you remember those from our day summary. When we get vectors of game days, we handle them differently. And our library, our file system library is helping us again. We're getting a directory iterator over every file that's in there. We go over each file and we can see, is the file extension .yaml? If it is, that's an interesting file to me. I load it as YAML. I add it to it. I convert it to a game day, and I push it back in my campaign. I pass that vector to my day summary, and then call my display code. Now, if that file wasn't a directory, it means it's just a single YAML file. I convert it to YAML again, pass it to the day summary, do the day summary thing for single YAML files, and then it goes to display. Nothing particularly magic there. Display summary is really simple. I iterate over my list of totals, or my list of entries in my day summary. Here I'm just figuring out what's the longest one because I need to properly align my columns in my output table. And then here I'm doing the output. Other notable things that make me happy about this code base. We're using CMake to build it. In here I'm using some new features of CMake. This came in starting, I believe, in CMake 3.11 and continuing improving from there. The fetch content feature, which lets me say I'm using a package that I'm going to call Google Test. Here's a Git repository. Here's the version tag that I'm interested in. And this makes it available to me. And what make available means in this case is it's going to download that particular release, and it's going to set some variables for me so that I can define where do the source files live and where do the executable that builds live. I'm doing that for Google Test, and I'm doing that for my YAML CPP library. This is all pretty standard CMake, but an item worth mentioning here is I've added a couple of tests, and these are really high-level acceptance tests. So in my example file, I have a couple of files that describe how I want my output to look. So for 1 day of output, this is kind of what I expect my output to look like. In fact, that is the output for running experience table on the experience.yaml file. If I give it a whole directory, this is the output that I want to see. And so all that's happening is in that test is I'm calling this script, which runs the program for a given input. So if let's input the example directory, one file, and it's just going to compare it to the expected output, this oneday.txt, or this campaign.txt. And this is a simple, crude sort of test, very unsophisticated, no test frameworks or anything. But this helped me deliver a working product much faster than I would have otherwise. I already had that test, that file that said this is how I want to see the output look. And by having that reference to check against in an automated way, I was able to drive to completion really fast. Now, because I'm a big believer in test-driven development, I have this test suite for any of the logic in the program is in here too. And I won't go into this in depth, but I am using Google Test in here again. Google Test is far and away my favorite test framework, actually in any language. It just makes it really easy to test. It makes it easy to mock things out when I need to. And having Google Test really sped me along. Instead of spending a lot of time overthinking stuff, I would have a test say this is what should happen when I do this, and it kept me clear and focused on I'm going to do this thing. So thank you for taking the time to listen to me, and I hope to talk to you later.